Welcome back to 3 Inquisitive Kids. In this video, we will be starting Chapter 10 of our 8th grade math lessons, which is Introduction to Translations. Here's our course outline for this chapter. As you can see, we have a total of 7 videos, and we're going to be starting transformations. What are geometric transformations, and how can we apply them to problems? Our learning goals for today is to understand the concept of translations, be able to find the translation of a figure, and be able to apply translations to solve problems. How can you draw a row of Nicks with the same shape and size on a piece of paper? If you don't know who this is Nick from the movie Zootopia. As you can see, we are moving him along where this arrow is pointing. And as you can see, we've translated Nick from here to here. Did the shape, size, and position of Nick change? Well, we know that the shape and size remained the same, but his position definitely changed. We moved him to the right after all. So a translation is a geometric transformation that moves every point of a figure or shape by the same distance in a given direction on a plane. Remember, the last part is very important. On a plane. Here we have triangle ABC, and this is how we translate it. We moved A to the right to get D, we moved B to the right to get E, and we moved C to the right to get F. If you measure all of these lines, all these 3 lines, they will be the equal because each point moved the same amount of distance. Determine whether or not the following transformations are translations. A is not a translation. B is not a translation. C, yes, it is a translation. It's being moved from the left to the right. And D is not a translation. A and D are actually other transformations in geometry, but we haven't learned about them yet. A, I'll give you a quick preview, is something that's called a dilation. D is something called a rotation. How are the following examples similar to translation? Here we have a well that's moving up and down. And we have items on a conveyor belt in a factory. Here we have a bird flying. As you can see, when it's moving up, its shape did not change, but its position changed. It's the same with when you're sledding, when you're sliding open a window, or when you're sliding open a drawer. If you think about it, the word translation is very similar to the word sliding in daily life. Conclusion. Translation is not necessarily just horizontal or vertical, and translation is determined by the direction and distance. For example, when you are translating something, it doesn't have to be moved just up or just horizontally. It can also be moved diagonally as long as its shape and size does not change. And in order to translate something, there are 2 variables you have to confirm. One is its direction, so in which direction are you moving this figure, and for how much are you moving this figure. How many units to the left, how many units down, how many units up, how many units along this slope, how many units to the right. As shown in the figure, triangle ABC is translated to get triangle A', B', C'. Analyze the relationship between the 2 triangles. First, we're going to draw a line from each of these points. They're all parallel, and they're all the same distance. So we're going to form a new triangle called triangle A', B', C'. What is the relationship between the 2 triangles? We can see that A, B, and C each corresponds to points A', B', and C'. The line segments AB, AC, and BC each corresponds to line segments A', B', A', C', and B', C'. Triangle ABC is translated to triangle A', B', C' along PQ. What do you notice besides the corresponding line segments being parallel and equal? Here we have triangle ABC, and we're going to translate it along PQ. Now we have triangle A', B', C'. You can see that each of these line segments, A', B', and C' are all parallel to PQ. A moved to A prime, B was translated to B prime, and C was translated to C prime. And A prime is parallel to B prime, which is parallel to C prime. A prime is equal to B prime, and also equal to C prime. Now we're going to translate this one more time. Has the midpoint of BC, M, shifted? Well, point M also moved because it is on the triangle. If you connected a line, M prime would be equal to A prime and also parallel to A prime. Now we're going to translate triangle A prime, B prime, C prime along RS to get A double prime, B double prime, and C double prime. We can see that the figures are congruent when you translate something. In terms of geometry, because triangle ABC is translated to triangle DEF, therefore triangle ABC is congruent to triangle DEF. The corresponding line segments are parallel and equal. Because triangle ABC is translated to triangle DEF, therefore AB is parallel to DE, AC is parallel to DF, BC is parallel to EF, AB is equal to DE, AC is equal to DF, and BC is equal to EF. Corresponding angles are congruent also. In geometry terms, it would be, because triangle ABC is translated to triangle DEF, therefore angle BAC equals angle EDF, angle ABC equals angle DEF, angle ACB equals angle DFE. The line segments created by connecting corresponding points are parallel. Because triangle ABC is translated to triangle DEF, therefore AD is parallel to BE is parallel to CF, and AD is equal to BE is equal to CF. And that was all in the terms of geometry. Here's some practice. After translating, vertex A of triangle ABC has translated to point C. Draw the position of triangle A prime, B prime, C prime after translation. First, we connect C prime. And now all we have to do is translate each of the other points along this line, which means it has to be parallel to C prime. And the lengths of each translation also needs to be the same length as C prime. And then we can connect the dots to result in the translated figure triangle A prime, B prime, C prime. Which of the following statements are false? A. Every point in the figure moves in the same direction. That is true. Every point in the figure moves the same amount of distance. That is also true. Every corresponding line segment in a figure remains the same length. That is also true because the size and shape does not change. D. There can be fixed points in a figure. Well, translating is all about not being fixed. It's about moving. So D would be our answer. After translation, vertex A of triangle ABC is translated to point D. Explain how you would translate the rest of the triangle. First, we can connect points A and D, and then we can make a line parallel starting from B, and you have to make sure that AD and B and this point are equal. We can do the same with C. Remember, all these red lines have to have the same length. Then you connect the dots to get triangle DEF. Follow-up number 1. Translate the letter A by 3 centimeters along the direction indicated by the arrow. Of course, right now we are on a screen, so you can't really translate this letter, but I want you to practice, maybe on a piece of paper, translating something to the right. It doesn't have to be by 3 centimeters, of course. If you have a ruler, it's best to use 3 centimeters. Again, first you identify all of the vertexes and points. Then you translate each one with the same distance and same direction. And then connect the dots to get your translated figure. Translate the letter N to the right by 3 centimeters horizontally. Again, we're going to translate each point separately. And then we're going to connect the dots to get the letter N translated. A rectangular lawn 21 meters long and 15 meters wide is shown. There are 2 trails with a width of 1 meter on the grass. The rectangular lawn is covered with grass except for the trails. What is the area of the grass? Here you can see we have figure 1 and figure 1. This is so we can show you 2 different solutions. But you can tell that we're starting to do some word problems. So how can translation help you in this problem? In the first solution, we are moving all of the yellow parts together. All the yellow parts is the grass. In the second figure, we are moving all of the roads to the left and top. So we are left with a full chunk of rectangular grass. The picture shows a rectangular lawn with a length of 21 meters and a width of 15 meters. There is a path with a width of 1 meter on the lawn. The rectangular lawn is covered with grass except for the path. What is the area of the grass? So how can you use translation to help you? In this problem, all you had to do was move the orange part on the right to cover up the path, and then you can later multiply to get the area of this new orange rectangle, and then that's your answer. The side length of the small square in the figure is A. How would you represent the area of the entire shaded part? Again, you can use translation to help you here. We're going to move the triangle on the right to cover the triangle on the left. That leaves us with a full piece of shaded square. That's A squared. Class summary. Today we learned about the introduction to translations. Its definition is, translations on a plane is determined by the moving direction and distance, and corresponding line segments are parallel and equal, and corresponding angles are also equal. The size and shape does not change. I hope you enjoyed this video, and be sure to come back for our next lesson on translations.